Hi everyone, this is Christian Ramirez, and in today's demonstration, we are focusing on MapView sections view code injection using custom payload generated through the Sliver C2 framework. Before we begin, let's quickly recap what process injection is. Process injection refers to techniques that allow an attacker to execute arbitrary code inside an already running or remote process. This helps blend malicious activities into legitimate workload. What is the goal of MapView code injection? The goal is to inject a payload by creating a shared memory section between our loader and the target process. By mapping the same physical memory to two different virtual addresses, we avoid using WriteProcessMemory, which is a primary trigger for Microsoft Defender or other antivirus/EDRs. This allows us to evade Defender hooks by sliding our Sliver bitcoin in memory without the usual load of API signatures or cross-process memory write alerts. Let's go through a step-by-step of the breakdown of using this diagram. Essentially, there are 5 steps that we have to take to execute this code injection attack. So in here we can see that we have our implant. We call it MapView.exe, and this one is the remote process that we are going to use to inject our malicious payload, in this case Sliver, right? So the first step is create a name section, right? So we start by creating a new memory section object. This is a block of memory that can be shared between processes. How we do that? We use NT-create-section API, right? We move on to map view in local process, right? And we map a view of this section into our process, so we have a place to write our data. How we do that? We use the NT map view of section API. It's basically this, right? The next step will be load or decrypt or write our shellcode. We prepare our Sliver C2 payload. In this case, we are using Sliver, and write it directly into our local mapped view because the memory is shared is now ready for the target, right? So we use this one. The next step will be map view in target process, right? Basically, we map the exact same section object into the target process. Like for example, can be notepad. In this case, we are using task host w.exe. How we do that? We use the NT map view of section API. And basically in here, this in here, and the remote process and the local process, they are sharing the same memory, and they can see and our payload. The last step will be execute the payload. So since the code is already inside the target memory space, we simply need to point a thread to begin the execution. We do that by using RT create user thread or create remote thread APIs, which will be this section. And from here, once we have it, we copy in here, we have it in the map section, we just execute it. Boom. Right. So now let's jump to the actual code. Let's start by explaining, and basically this is our Sliver payload, and we have a global function called isDecrypt in place, that is the one in charge to decrypt our Sliver code and memory, right? So basically, this is something that we have been discussing in the previous videos, nothing new. So we have another global variable function, sorry, called find target pit. So it's something that we have been using in the previous demos, right? And nothing new in here. So, and this is the section right now, and where all the magic happen. And we also create global function called inject via MapView section. The first block of this uh, function um, is basically is a code that dynamically resolves three undocumented APIs. The first one is nt create section, nt map view of section, and the last one rt create user thread from the nt dll.dll at runtime. Checks that they are successfully obtaining and initialize the necessary variables to prepare for creating and share memory section that will be later mapped into both the injector and the target process. Right? So let's also explain, for example, get model handle. Basically, get model handle, what it does is it returns a handle and a base address to a module. In this case, can be a DLL or the executable itself. So the portable executable itself that is already loaded in the current process address space, right? So the other um, thing that I want to explain is get proc address. What get proc address exactly does is given a module handle from, in this case, get module handle, that also can be load library, but in this case, we are using get module handle, and the name of an exported function, it returns the memory address. In other words, the function pointers of that function. Basically, it allows runtime resolution of the APIs, avoiding having the function names appear in the import address table, right? So, and from here, so we already explained these steps. We create the section, right? We use nt create section, right? Map locally, and we basically, and we are in here, right? So this was the create name section, right? So map view local process, right? And the third step is write our payload, and we are in here, load to the crypt and write, right, our shellcode or payload. The next step is map the view remotely, right? And this one, map view the target process remotely. In this step, and finally, we execute the payload, right? We executed using rt create user thread, right? In this case, so execute the payload. So basically, from here, so we can execute and our shellcode or our payload. After that, we have our main function. So basically, we are just adding here the remote target process that we are going to use. In this case, is task host w.exe. We use our previous global function that we declared previously earlier, and we open the process, right? And everything goes well, right? And we call our eyes the crypt in place. That basically is the one that we declare here to the one is in charge to decrypt our shellcode payload and memory. And after that, we call our main global function of this injection technique inject via MapView section is the one that we just explained. Yep. And if everything goes well, so we are going to get Sliver beacon. Now let's jump to the actual demonstration. This in here. So we don't have our implant. Let's compile it. We just got our implant. So we have our target process. So one thing that I wanna mention is that right now in 2026, this type of techniques is still being undetected by the Microsoft Defender. As you can see, is still the protection on. So let's execute it and let's go through the process. So I'm here and we the implant started by looking for the process. We found the pit is 4568, which match in here, right? And after that, we got the handle, and we move on to the decryption portion of our payload. Was decrypted, and we start the MapView injection. That's our section. Our local view, in this case, to see our local view, and let me just press. Okay. We as in here this portion we are going to map our payload and memory. Let's go to map view, and map view we are going to memory. In memory, let's try to find our section is called local is 23 28 23 28. Let's see, 23 28 23 20 28 87 87A. I think it's this one. Let's open it. Yep, this is our payload or shellcode Sliver. Let me just confirm the address is correct. 23 28 87 87 800. Okay, yeah, is this one. So now let's open the remote process and view this section of memory address. We have to go to let me just move it in here. A little more. That's is this one. The pit still match. Okay, we go to memory, and we are going to try to find oh Jesus. Okay, the address is 24BA 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 08 2000, which is this one. So if we open it, and now we go and compare these two memory address, we can see that our Sliver Bitcoin has been shared on the target and remote target process. One of them is for the MapView, that is on our original implant. And in the left window, we can see that is the task host process. And we can confirm that the technique has been executed successfully, right? Now, the next step is just to confirm that our Bitcoin has been executed. And in here, we can see in our redirector that that is working really fine. And if we go back in the Sliver, we can see that we got our implant, right? And we can determine and um, a few of the type of context that we are right now. So we the pit match, right? So our pit is 4568. That's SW 4568, right? So one thing that I want to mention in here, I'm going to show you that the AMSI function invoke mimikatz invoke mimikat. I think it's called in okay. Okay, we can see that our the AMSI is enabled, right? And we can even also demonstrate that. In here we go to modules. We can see the AMSI is up and running. So the next step in here, this did we put the interval 10 seconds, jitter 15. Of course, this is a bad offset, but we are doing this just for the demonstration purposes. The first command that we are going to execute is this one. So we are going to execute Seatbelt, but we are going to use the inbuilt command that come from a sliver to be able to evade or bypass the AMSI and also the ETW on the user space, non-kernel space. So let's execute it. Let's just wait. It says has been sent. And as you can see, it was executed successfully. And no alerts, no nothing in that site, right? So the next command that I want to show you is another variation. In this case, we are going to execute the same tools, Seatbelt, but we are going to use a different approach. We are going to use approach called fork and run. Basically, we are going to spoof a, a bit. We are going to use a process, our same process, right, with specific arguments, right? You will see it. So we are going to execute it. And if we come here and everything goes well, yeah, we are going to see a new process, right? And as you can see, our arguments match. We add the $0 $, right? And it's executed in memory, right? Let's see the .NET assemblies, right? And let's just wait till this command finish. Okay, it finished. No, not yet. It's sent. Okay, let's just wait. It's still executing it. It's taking time. So, let's just wait. If everything goes well, we are not going to be detected by Microsoft Defender, neither the AMSI model or the ETW, and we are going to get the results. Okay. Okay. So finally, we got the result, right? So the command was successfully executed, and no detections on Microsoft Defender. So we confirmed that the injection was successfully executed along with the post-exploitation with no detection at all from Microsoft Defender or the AMSI or even the ETW, right? Yeah. I guess to summarize, in this video, we demonstrated how MapView code injection can be used to stealthily execute a Sliver C2 payload inside a legitimate process, right? This approach is a key area of offensive research because it shifts the focus from writing memory to mapping views, which defensive teams must account for. So once the sliver payload established a session, we transited into the post-exploitation phase. We started by using the info command to confirm our current user context. Next, we move on to utilize the Armory to load Seatbelt, which allowed us to gather critical system information and enumerate security policies. Uh, the, the execute assembly feature built into Sliver facilitates remote process injection via the fork and run method with the appropriate PPID spoofing, as well as the self-process injection. The self-process injection enable us to use the inbuilt in AMSI and ETW bypass, right? If you want additional breakdowns, source code for this example, or hands-on operation training, join to our Discord at RBT Security. If you are enjoying these videos, make sure to subscribe so you don't miss the next attack demonstration. Your support helps us continue producing more cybersecurity content every week. If you found this technique interesting, please share this video with your friends, teammates, or anyone in this security community who might want to level their skill.